Hello and welcome to our webinar. It's now 9 minutes to. So, hello and warm welcome to our webinar. It's now 1 minute past 4 o'clock Central European time. So I think it's time for us to kick off this webinar today. This webinar has got the title, How to Strengthen Your Sustainability Strategy by Introducing Predictive Maintenance on Refrigeration, Air Conditioning and Heat Pump Systems. My name is Lars Dahlberg and I'm acting as the moderator today. I'm going to guide you during this webinar. This webinar is arranged by the company ClimaCheck. So with that, I think it's time for me to start to introduce what you will learn during this webinar. And we have really lined up quite a lot of interesting content for you here today. So let's take a look at the content that we will go through. So as you can see, quite a lot of things that we will go through, quite a lot of interesting questions that we will deliver answers for. So to begin with, we will talk about why the increased focus on sustainability will force companies to focus on sustaining performance in HVAC&R systems. We're then going to move on to talk more about the unseen challenges with the HVAC&R operations and the potentials for energy savings. We will then move in and talk more about what predictive maintenance is all about and how to implement that on HVAC&R systems. We will also talk about how you actually work with improvements in real life scenarios. What results can you expect from implemented predictive maintenance and how to assess your own savings potential. So you will be able to actually do that after the webinar with the help of tools that we will provide you with. And then finally, we will cover how and why energy efficiency and predictive maintenance is connected and asset management to increase sustainability. So it's quite a lot of things that we will cover. And in the end of this webinar, we will run a Q&A session. So you really have the opportunity to ask questions for our expert speakers. And when you ask questions in GoToWebinar, you can just check your control panels. And on the control panel, you can find the functionality for typing in questions. And I really stress that you can type in questions whenever you have the questions, and we will answer the questions in the end. And the rest of the audience, they will not see your questions. So it's only us that are delivering the webinar that will see your questions. So please take the opportunity to ask whatever questions you have, and we will answer them in the end of the webinar. The webinar is expected to go on for approximately 60 minutes. And now it's time for me to introduce today's expert speakers. So let's see if we have them online. And here we go.
So we should be here. Hello.
Yeah, it should be. Maybe Niklas, if you can switch the slide as well, so they can see your contact information. Thanks. So with us today, we have, I'll start with you, Niklas Berglöf. Welcome to the webinar as the experts, one of the expert speakers.
Thank you very much, Lars.
And we also have Rupen Arnesian with us today as the second expert speaker. So welcome, Rupen.
Thank you.
All right. So we have prepared a lot of things, and I think it's time for me to hand it over to you, Niklas.
Yes. Thank you very much, Lars. Then we will go on and welcome everybody. It's nice to see everyone here, and I really hope you will find this approximately 1 hour interesting. And yeah, we will talk a lot about predictive maintenance today and how it can be used to increase sustainability. And of course, why is this important? Yeah, because there is a huge focus on sustainability in the world today, and that will force a focus on HVAC&R system. So because why? Let's see. So why will the focus increase on the HVAC&R system? When we talk about HVAC&R, it's air conditioning, refrigeration, and heat pumps. We are looking on refrigerant circuits in ClimaCheck. These systems are consuming 20% of the global electricity, and it's growing. It's also known as the cooling paradox, where the colder or the more air conditioning we want, the more we heat, because by cooling, you generate heat. And those systems consumes 30 to 60% of the electricity in buildings. So 20% on a global scale, the major consumer in buildings, commercial buildings. And then what we see is that the saving potential is 10 to 30% on the electricity side. Then we have the maintenance side, where you can save a lot as well, which we hope will be very clear during this webinar. And yes, of course, the pressure. Why is this now? We have the saving potential, but the environmental pressure is also increasing now. We have non-governmental organizations, we have governmental organizations, we have individuals that is pushing environmental questions to reduce climate, reduce CO2 emission. But we also have costs in this. Now, last year we had high electricity cost in Sweden. This summer seems to be similar. We also have a situation in Europe where we would like to reduce our, we need to be more self-sufficient, we need to reduce fossil fuels, etc. So everything is connected now to reduce energy consumption. And who are we? ClimaCheck. Some of you know us already. But we are what EKG is for heart analysis. We look into the system, the heat pumps, the chillers, the refrigeration, the air conditioning units, and see on a component level, how efficient is this system compared to how efficient could it be. When we started 2004, we were delivering everything on an own basis, all the sensors and all the tools, all the connection tools to get the systems online. Nowadays, our method is, it's unique still, it's international approved, and many sensors are available today. So it's quite easy to take the next step into performance analysis and all the benefits of this. And like I said, we've been around since 2004. Today we work with many of the major property owners in Sweden. We work with hospitals all around the world, everybody with one goal, and this is to increase sustainability, reduce power consumption, and of course, reduce failures, because failures is a huge cost and consumes a lot of time. So let's dig into the HVAC&R systems. Like we said, it consumes around, let's say, 30 to 60% of the building. But when optimized today, you are usually looking on HVAC optimization, but that's actually the fans and ventilation, pumps and valves. So it's the distribution of energy. What ClimaCheck adds is that we are looking into the energy production, the source of this, of the energy. And that is a huge energy consumer in the system, which means that even if you make great savings, and this is a common thing we see, you do great savings by fixing the pumps, you change the condition, for example, the heat pump. So you get a sub-optimization which ended with an increased power consumption in total, but you did savings in one part of the system. So to avoid this, we are working very strong to add this system or this analysis. And of course, so why isn't this done more? Why don't we open the black box in every system to avoid sub-optimizations? And I would say this is one of the big questions we have today, because right temperature is not a good measure of performance. So this means that even if you have, say, 22 degrees inside, it's not necessarily they're efficient. And this, like we mentioned before, heat pump can deliver a temperature very inefficient. So it can deliver 20 degrees with potential to optimize 20%. And this is a big problem we have today, that you assume that the performance is good as long as you have the right temperature. And on the picture here, you can see that one of these things that's good to know is that a conventional SCADA or BMS system is looking into mostly the distribution. is system boundaries 3 and 4. So how do we get the energy from point A to point B? What we add is that we look into the heat pump or the chiller. How is the system going there? And of course, we work together with many of the main companies and integrate with each other. So we supply the analysis into the system. So how does this look when you have this information that creates all the opportunities? Performance analysis for us, this is the highest level of the information. We have chosen to summarize it in a dashboard like this. And what we show is system efficiency index. That is quite different compared to if you take COP or kilowatt per refrigerant ton, because system efficiency index looks on how efficient is the system performing compared to how efficient is it. And this gives you a map directly to, is it performing good for my system? Is it, and even take account ambient temperature. So you don't need to do other calculations. If you know that my system is supposed to have a system efficiency index on 43.6%, which is here, and that's good, then you know it's fine. You can move on to the next system. But if you are expecting a higher system efficiency index, then you can directly look into the sub-efficiencies. Where do we have the potential to save, or why is it not performing as it should? And this is, for example, we could say the compressor here, the efficiency maybe should be higher. Perfect. Then you know where to start looking, and you can dig deeper into the analysis and come to conclusions to what to do. And this, of course, leads to the next question or next possibility. You can optimize the system, but you can also predict. And this is where predictive maintenance will be a big part of the future as we see it. Because when you can detect deviations directly when they happen, you can fix them. So instead of running a system to failure, which sadly is quite common now in Sweden, it starts to get hot, and air conditioning system, they work during the spring or early summer because the load wasn't too high. But then when you get that peak day with a very, very hot climate, it can fail. And this we see many, many times, that it's not hot weather that creates those failures. It's bad operation over a long time. And this is what we will dig into today, how to fix those problems or how to avoid this. And of course, you will have fewer alarms when you can remove the deviations early. So you act on early signs of failures instead. And what we also see now, we build a digital twin of the system, and this can of course be used to benchmarking between building systems within a whole organization. So, talk about the organization. We know that sustainability is crucial today, and a big part of that is energy efficiency. But we know this, but why isn't all organizations optimal? What we see now, what we discussed and identify as big problems is that, or as challenge for organizations, this is the reality. So no organization have staff with all the competence. And of course, it's impossible. I mean, we are looking on thousands of systems every year. You can't demand that a person that are responsible for many different things have that kind of knowledge. And of course, well, sadly, I would say, we usually see that even in an organization where you have maybe 50% of the consumption is the HVACR system, you don't have the responsible person for the HVAC system performance, which means that, once again, if you have the right temperature, everything is accepted to work. Breakdowns, it's a part of the business. It's sadly, we see that it's accepted, but of course it should be avoided to any cost. We have a difficulty in many organizations to get a good overview. You have silos between managers, and all this sums up to business as usual, which I would say is a huge problem, because it's easy to stay in business as usual, but nowadays we need to move on. And at the same time, you have the outside pressure from the organizations, from laws, regulations, groups of people to actually reduce cost, reduce energy consumption. So in the midst of all this, you need to move forward. So business as usual. These are the two most common maintenance methods today. Preventive maintenance, which is scheduled or based on time. So it's run time, for example. It's performed a couple of times a year. Maintenance is important and crucial, you will always need some kind of maintenance. And this, of course, increases lifetime. Preventive maintenance is possible in many business as usual scenarios. The challenge with it is, of course, it does not detect deviations. It's expensive in the long run because the goal is not to fix systems when they start to run bad, sadly. And I would claim it's ineffective because if it's scheduled to go to a site, you would go to a site and perform the maintenance and then go back. Doesn't matter if it was necessary or not. And then, of course, we have reactive maintenance. I would say no one would buy reactive maintenance as had that as a plan, but a lot of maintenance are reactive. It fits in business as usual, and it's a low initial cost because basically you say the system is running, good. If something happens, it happens. This leads to more breakdowns than necessary. Complaints from tenants, staff, it's not good. When you have a breakdown, the risk is that you damage the whole system. And of course, change a compressor, for example, can be a couple of thousands to tens of thousands of euros. So the cost of a failure is usually much, much bigger than the cost of avoiding it, or it is, even if you need to implement new systems. So this is how it works today. The future, I would say, is predictive maintenance. Instead of some maintenance, it's good to know, will always be necessary. At some point, you will need to go to a site. But looking on the condition, you can plan that in a completely other way. If the system tells you, like, okay, this compressor is losing performance, and so it needs to be checked, you can plan the service visit. And I'm earlier from the IT industry. These were made all the time. Like when the system lost, I think 12% of performance for a server, someone would call the owner and go there. This is today basically possible in HVAC&R systems as well. This avoids breakdowns. It is cost efficient. It is a huge part of Industry 4.0 to have a more efficient operation. It leads to increased lifetime, energy savings. It's good to know that predictive maintenance is not necessary energy optimization, but energy optimization is a normal thing out of predictive maintenance, but you can optimize a system without working with predictive maintenance. And of course, you have a better working environment. No one likes those jobs that start in the middle of the night because it's panic. When you can plan it, it's better for everyone. Of course, you have the cost. You will have new equipment, you need new equipment, you probably need to train someone for this training. But that is fine. But I would say the biggest challenge is that, and everybody asks all the time, how much could you say, what is our return of investment? Rupen will show later some example of this, but it's not always clear how big the saving is initially, because we are missing information, like what is the cost for the inefficient system? What is the cost for a failure? What is the actual cost for having someone going to site in the amount is now? Is it necessary? So a big challenge to leave business as usual is that the value of moving forward isn't clear in all organizations. But we know that it's possible to save 10 to 30% of the energy and have a more efficient maintenance. But also, it's not only ClimaCheck that is claiming that this is good. We could see that the US Department of Energy, they, a couple of years ago, compared predictive maintenance to common maintenance methods, reactive or preventive. They could see that if you invest in the beginning, you would, over the lifetime of the equipment, get a good return on that. You would reduce maintenance costs again, you would eliminate breakdowns with 70 to 75%, which of course is huge. Reduce the downtime and increase the production. So it's a lot of good things, and having numbers of this, then you need to measure it all. So it is a challenge to say how much could we save before you start to measure. But one thing that is clear is that our efficient systems are reliable. So how to go there? How do we get all these savings? How do we improve the sustainability work? We have developed the 9-step method, DDOP. It's data-driven optimization and predictive maintenance. And it actually starts in that you need to start to establish a baseline. Where are we today, energy-wise? Where are we with maintenance costs? One of our customers, they are heavily driven by the maintenance cost, and they want to move the cost from the reactive costs to the preventive or predictive costs. So they have a good strategy to, can we avoid these failures by putting in money initially? So they're working in a very structured way to do this. You also need to define what data should we collect in new systems and as well in existing systems. You need to define how it should be transferred. And this is not only for predictive maintenance. This is a huge part of Industry 4.0 and Internet of Things. Like, you need to have a structure on the data. Otherwise, it's just data in itself, it's just numbers. You need to have a way to analyze it. And then, of course, you need to have someone responsibility for this. How is the data collected? How do you communicate it to get the information? And then when you have the information, you need to have someone that is have the responsibility for the analysis. And of course, when this is done, you need to ensure that it's correctly, you get the right information, that everything works. And then you can establish a procedure for predictive maintenance and optimization, because you need a lot of information. This process don't need to take a lot of time, but it's need to be there. So before I'm letting Rupen show you how the magic works in this system, we can just say, if you don't have a plan, you will have no or a very bad result. So by implementing, going into Industry 4.0 and the Internet of Things, performance analysis is possible. And the economical and environmental potential is, I would say, quite big. And Rupen, if you take over here and
thank you. So talking about economical and environmental potential, we're looking at maximizing our energy, how much cooling, how much heating we can get from our system. We want to maximize it, even we want to reduce our electrical energy consumption. We have lower maintenance cost, we have fewer breakdowns, which the cost is usually not really taken into account, the breakdowns, but they have quite a high cost, and it's not really something that is planned for. Regarding environmental potential, we can strengthen the company green profile and reduce CO2 consumption, CO2 emission. What are the typical problems that we usually find? Now we are looking at the refrigeration system and the actual components in the system. So we have the refrigerant, it might be overcharged or it might be leaking. We have the compressor or the heat exchangers, they might be performing not so well and they need to be either fixed or changed. We're looking at the pumps, and the controls is a big issue. Now, I have listed here quite a lot of issues, but what's important here is that none of this is expensive. Most of these things are cost basically not so much investment, and they will be able to save quite a big chunk of the energy. We're looking at 10, 20, 30% savings in the supermarkets, heat pumps, ice rinks, in these industries. So whatever measurements that we've done, we're looking at 10 to 30% energy savings by checking at the components of the system. So how do we actually do that? The predictive maintenance in practice. So we've talked about our plant, our system, and most of the time we're focusing on the temperature that is arriving to the users. Now, this is normal because users that's what they feel. The temperature needs to be warm or needs to be cold, and that's what we want. But the benefit of having a predictive maintenance is that we will also be able to save energy and to have a better optimization of our system. Now we're looking at the chiller, heat pump, supermarket rack. So this is where the cooling is created, or the heating, if we're trying to heat our system. So this is what we're focusing on. And this is most of the time neglected. We just think that it's performing well. Because we are getting our temperature, then we know that the system is performing well. Most of the time, that is not the case. And that is why we want to focus here, because most energy consumption is happening in the chiller, heat pump, the refrigeration cycle. So how do we measure that? We have our method, which has been published also in the International Energy Agency, Annex 52. We have the link for this at the end of the webinar. Now, the conventional system to measure the refrigeration cycle is to basically consider it as a black box. We're looking at the temperatures in and out of the system, the pumps, the fans, but the actual refrigeration cycle is taken to be a black box. What we like to do is to dig into that black box, to open it, to look the sensors, how they're working, how the system is working, how each component is performing, and how we can improve it. Now, this is called the internal method, and is basically based on thermodynamics. And what we are aiming to get from this internal method is the analysis of the whole system, the system efficiency index, and the efficiency of each component, the compressor, condenser, evaporator, the cycle. What we can also get from it is fault detection, to predict if something is going to happen and to be able to fix it before any breakdown or failure. We can also have optimization and the benchmarking compared to other systems. Now, measuring is not something new. Sensors are all over our systems. Here's an example where the maintenance goes down every hour and writes down the sensors. This is not something new. Question is what we do with these values. In this case, they're just writing on a sheet of paper, and just forget about it. What we do is to take those values and transform it into information that can be used to analyze. It can be used to have the predictive maintenance. The dashboard, we looked at that, but what we're looking here is the system efficiency index, which is a KPI that we've developed together with the Institute of Refrigeration in UK and a research institute in Sweden. But this does is to compare our system to an ideal system without any losses. So what we can see is how our system is performing and how each component in our system is performing and how we can save energy on each of these systems. Another tool we have is the energy consumption, and I will be digging into those two and give some examples. So how do we work with improvements? Now that we got the data, we've created our dashboard, we have our tools to do the analysis. So the first example I will be looking at is the system efficiency index, which basically shows how our system is performing. Now this is irrelevant of the boundary conditions, so it takes into account if it's a warm day, we do expect that our system will not work as efficiently as on a cold day, but this system efficiency index takes that into account. So we can see how well it's performing depending on the conditions. So this is an example where we have 4 heat pumps, and we're taking data which is already there in the BMS system. So we're taking that with Modbus and using our tool to do the analysis. Now here, what we can see is heat pump number 2 has a very low system efficiency index compared to the other heat pumps. Now there are 4 heat pumps. In this case, it's very easy to compare them. We know how the others are working. We can see that this one is not working properly. And in this case, it's quite a big issue because we're talking about the compressor. Now the compressor is working terribly and it's about to break down, and it can happen anytime soon. So this is the results that we got as soon as we started the measurement. We can see directly that the compressor is not performing well. In this case, because it was an extreme case, then we had to stop the compressor. So we contacted our partners who are responsible for the system, and we asked to shut down the compressor and to basically change it. This is an extreme case where the compressor is performing terribly. And what we can see before and after the change, that we've reduced the energy usage by 25%. Our system efficiency index, which shows the total energy of the system, was 26%, and now we have 39%. And the compressor efficiency, which shows how the compressor is working, it was 45%. That is a terrible performance compared to the change after a new compressor. We have 69%. Now, the results of this is that we've reduced the energy by 25%. Now, this is a case on small 4 heat pumps that we had just started measuring, but we've got some other cases here that we're looking at an optimized system. So we have our system, we've optimized it, but we still find some issues. And in this case, we will be using the energy signatures to find those issues. Now we have the energy statistics. This is a very long measurement representing the energy consumption during the whole year. We're looking at how much our system is using, and we can also compare it to the ambient temperature. Now, there is a connection between the ambient temperature and the energy consumption. As soon as the temperature goes up, we have higher, warmer weather, we have higher load in, this is a supermarket system, so we have higher load in the supermarket system, and the actual rack will be performing worse. So that is normal, and this will create a connection between the ambient temperature and the energy consumption. And this will be the energy signature. And for this case, it will look something like this. Basically, it says that as soon as the temperature, ambient temperature increases, our energy consumption increases as well. Now, this is a typical energy signature for a supermarket system where we have a base load, where we want to cool it always, even during winter. But as soon as warm weather comes, our energy consumption increases. Now, what can we do with this energy signature? Because we've got the data from the energy signature, we can predict and say that at this temperature, we know that the system usually consumes this much energy. So we can predict what the energy consumption should be. And if it deviates from whatever we've predicted, then we know that there's an issue. Now, this is the graph that we looked at. And on top, we're adding the predicted energy consumption. We've based this based on the energy signature. Now, most of the time, it fits quite nicely, except here. We're looking at energy consumption, which is much higher than what we've predicted. Now, let's take a closer look in here. So what we predicted is 540 kilowatt hours, but we're actually using 685 kilowatt hours. This is quite a lot of difference. And at this point, our partner got the alert from our system and wanted to dig deeper into the data to see what is causing this issue. So looking at the system efficiency index, we're seeing that the overall system is performing terribly. And the reason for that is the condenser. Now we've got issues in the condenser. We take a look at that. And in this case, the problem was the fan inverters. They were not behaving as they were programmed to be. Now, remember, this is a system that has been optimized. We've done quite a lot of analysis already. Our partner has been there, fixed with the contractor and so on. And this is happening after a year or so. We're on an optimized system. It is not uncommon to get frequent issues even on an optimized system. And it's important to continuously monitor to catch these issues. Now, at this point, we got an alert of high energy consumption compared to what we had predicted. And what we're having is that we have an issue in the fan inverters. And at this point, the contractor has been there and fixed the issue. Now, this is taking a few minutes. We know exactly what the problem was. The contractor doesn't need to waste time by going there and checking everything again. We know exactly what needs to be fixed, and it has been fixed in a matter of a few minutes. And the results, we've got reduced condensing temperature, a much more stable system, and we're talking about 20% energy reduction. So if we didn't do this change, this system would use 500 kilowatt hour during the day. But because we've made this simple change, now it's using 400 kilowatt hours during the day. This is a third example using also the energy signature, the predicted energy. And in this case, we see gradual increase of the energy consumption. At this point, we have an issue with a leak. So refrigerant leakage, and this has been fixed, and the energy consumption goes back to what it was predicted. Again, it's important to continuously monitor even optimized system. Most of the time, systems are set to be commissioned, but they're still work non-optimized way. But even if they're optimized, problems will occur. Now, this is a bigger example that we've had with Banner Health. It's a hospital chain where in one phase we've done the analysis and they work with the predictive maintenance. In this case, they're saving 40 million kilowatt hours annually, and the estimates exceed $1 million. And the problems that they have had is that even after optimization, they have found 24 issues within 6 months that affected the chiller performance 10 to 15%. Now we're talking about optimized chillers. These are state-of-the-art chillers. They're commissioned properly, they're optimized, but even after those optimizations, we're still seeing issues that can affect the performance 10 to 15%. Now, in this case, we're talking about a big plant and we have big savings, but the percentages is the same overall wherever we look at. We have very common savings, 10, 20, 30%, and issues that can be easily fixed. So what is the next step?
Yes, thank you very much, Rupen. Yeah, so the next step, I mean, we see now that it's possible. The systems are there to analyze. There are the demands. It is with quite easy and cost-efficient measures to fix a lot of the problems that can be detected when you use this, for example, system efficiency index. I know, just for example, the case Rupen mentioned with the compressor. That we saw during the commissioning. So that system was just turned off when we were making sure that the values were corrected. So now it's up running good, but it is, you can see things very, very fast. But the next step, of course, how to start the change. We can see now that it's so important to reduce power consumption, but we need to change. So, of course, a big part of this is set requirements. And I would say it's not, we set requirements today, but we need to add the right information in these requirements. How is the commission performed? It needs to verify performance, for example. You always need to focus on the performance. If you start a system, you have some noise and something gets cold, that is not a good sign of performance. You should analyze it, and if this isn't specified, there is basically no one would go and check performance just because it's fun. So it needs to be specified. And then the second thing is someone needs to be responsible. Even if you have the right equipment and have the right information, you need to have someone that acts on it. We see very commonly that our system sends an early warning, and at one point, if nothing happens, we could see it as well. And then we have systems where we've been trying to tell an organization that you need to do something, you will have a failure, and nothing happens. Then they have a failure. Then we, on the good side, we documented the whole process leading to the failure. But if you don't have anyone responsible, it won't things won't happen by itself. And so these are the two: have good requirements that specify how it is done and who's responsible. And of course, energy efficient system, I said this before, is reliable. And the reliability, of course, is a big part of the predictive maintenance, keep it reliable. So a good request, we see that the prerequisites for efficient system, you need to have some specific points. This I've added so you could see it. But most important, like I said, or how to actually make sure that the information is used. The data collection today is good. We have huge BMS and SCADA systems that collect data. We can see that a lot of sensors are today on a heat pump or a chiller, for example. It's already there. But the system to make information of it needs to be there. You need to get the insight that is possible, and then you need to have action. And of course, these opportunities that you get needs updated service agreements. You need to replace them or update them, because otherwise we get in the situation where we have information, maybe you have the insight, but there is no action. So this is a crucial part of the process to actually change business as usual. Yeah, and we mentioned this before. This is the webinar that you can access. But also, we made a guide for this, and it ends up in what we mentioned before, like there need to be a procedure to take care of the information, because it's that action, that information that have a large value, a huge value. And this process, it do not need to take too much time. I mean, sustainability, yes, we want it now, and it needs to be, the steps needs to be followed, but we still see that savings can be very, very fast. So it's not, you need to monitoring for as long as you run the system, but the initial savings, as long as you have a good process, can be reached. I mean, over a couple of hours. When you do the changes, you will have the savings. So what is the expected result in the organizations? Of course, when you get a structure and start to act, you will have the responsible person, you have the communication. So we mentioned before that you have silos in our organization. So you will have knowledge share, but those are quite soft values. I see them as very important because I love teamwork. But you will also, of course, have higher profit. When you reduce costs, you have energy efficiency. You have efficient sustainability work. We usually see that you have, if you can remove 10-15% of half your energy consumption, that will leapfrog the savings for you. You will have reduced maintenance cost. It's important to know that predictive maintenance is a cost. It is a new service that needs to be asked for. It's something that you need to order. It's nothing that happens by itself. So of course you have costs, but you can still reduce the failures. That saves money. Of course, reduce CO2 emission. If you can catch leaks faster, you reduce energy consumption. You will have clear responsibilities in the organization. All this leads to a greener profile, improved sustainability work. And what I think is very important, like, to measure is to know. And this will keep on be valid for as long as we live. Because when you measure the performance, you can also show the result. So you can avoid the situation to get into a greenwash discussion, because you can show the result. We did this, we had this result, this is how much we saved. So you can actually prove that we are increasing our green profile. Reality check. So where are your organization? It can be a good way to check how far are we on the journey. I often get the question, how much could we save? How fast could I get return of investment? My usual question is, what is your energy consumption? And it's not sure. You usually get The answer, I don't know. So first of all, make a reality check where you are, what is our position. So that's the initial step to start this. Where are we? Then when you do this, we can look at it together, discuss what do you need to do, what is our recommendation, how can you start to including HVACR system into the sustainability work, because I would say taking this for granted will leave many organizations behind because they will carry large costs that is unnecessary. So this is will be sent out after the training, after the presentation. So you can access, you can fill it out, you can check what you need to have control of. If you fill it in, we can then have a discussion and help you forward, if you like. And with that, thank you very much. I will let Lars in here. Welcome, Lars. So questions, yes. Did we miss something that we've been talking about that we should bring up? So
yes, thank you, Niklas and Rupen. It's now time for the Q&A session. We have already received a number of questions, but of course you have the opportunity to type in all your questions now. So as I mentioned at the beginning of the webinar, just go to the GoToWebinar control panel and you'll find the functionality there for typing in your questions, and type in all your questions and we'll spend time here together with Niklas and Rupen to deliver the answers. So with that, I think it's time for me to start with our first question. So I hope that this one is clear. I'll read it out. So to begin with, in case of condenser fan inverter problem, how can we know if it is inverter problem?
Now, in that particular example that I showed, and should I go back and so in this particular example, we're looking at, we're also measuring the fan power, and the fan power usually is around 0.3 kilowatts. And here, when we see the fan power is around 8-9 kilowatts. So we've got a huge amount of energy going to the fans, and this is not really normal. Also, this the system itself is unstable. So we're looking at, here is the after adjusting it, and you see how stable is the condensing temperature, which is directly affected by the fans. And before, when the issue was happening, we're looking at a very unstable situation because the fans basically are turning on and off all the time, maximum power and then back to zero, maximum power and then back to zero. So this is what is causing, and this is what our partner could figure out with the contractor, that they might most probably have an issue with the fans, and in this case it was an issue with the inverters, which basically they could check that the controls was not set up properly.
Okay, thanks for that. So let's move on. We have another question, I think, complementing this one a bit. So we can learn that there is a condenser problem. Cleaning or inverter or oil fouling is difficult to know. This is not really a question. Maybe you can elaborate a little bit around this statement.
Yeah, I will. I think I can answer. So yes, if you have a bad performance of the condenser or the evaporator, there will be different reasons. There you have a different reasons which can cause a bad performance on the condenser or evaporator. And you should be able to check with other KPIs. Let's say you have a high condensing temperature, and that might be because your condenser is dirty, needs to be cleaned, or the fans are not running. So if you're measuring the fans as well, the fan power, you would be able to notice that the fan power is not really as it should be. Maybe it's just turned off, or in this case, you might be checking another KPI, let's say the subcool, and then you see that you have a very high subcool. In this case, you might want to guess that this system might be overcharged. So looking at just the condenser performance yes, you will know that there's an issue and there might be different reasons for this issue, but you're able to go deeper into the data and see which KPIs connected to the condenser show more information about what the issue might be.
Okay, thanks for that answer. I hope it clarifies. All right, so let's move on to the third question. How can I get involved in the UK? I don't want to directly install ClimaCheck, but I want to specify it. So it's someone that wants to specify it should be included in future systems, I guess.
Yes, yeah? And then, oh, sorry, Lars. Yeah, no, it's just to contact us. We have both Rupen and we have Klaus, that is another one of the founders of ClimaCheck. So we are very used to work with this. So if you send me an email, I will put you in contact, because we are looking into, I think it's SPF 40 in UK. So it's just get in contact with us, because we have those documentations for specifying prepared. So send me an email. We have them both in English and Swedish. So we can definitely help with that. So
yeah, you can see the email address here on the screen, but you will also get an email tomorrow with the contact information, so you can reply on those emails tomorrow if you don't have time to take down those around email addresses right now. So thanks for that one. And then we have another question here. It's a bit of a statement. Most air-cooled condensers are cleaned the wrong way. They need to be cleaned in the opposite direction or of the airflow. It's not really a question, it's kind of a statement. Yeah. Maybe you can comment on that.
Yeah, it's a good way to think about it. So I don't have much to add to that. It's important to know that most of the time the cleaning is done in a regular schedule, as Niklas mentioned, in a preventive maintenance. And then it's important to, in this case, to also notice that the condenser might have an issue. And when you're there on site, you will be able to tell if it needs cleaning or not, and hopefully clean it the correct way.
Yeah, and this is something we see very commonly, that I mentioned also already, that we have partners that is looking how to move the maintenance costs. And this is a very common thing, that before going to site, you check what's needed to be done, and then inform or fix that, and then show the result. So we have, I would say, in the whole industry, a challenge that a lot of maintenance is done based on, you could say 20%. And yes, in some cases you will, but instead of saying the possibilities, do action based on need will change some of these. It will change the intervals of this maintenance, so to say, in some cases. But yes, it is. Yeah.
Okay, thanks for that. Let's move on to the next question. Once you have optimized the system, how do you measure energy savings if the duty is continuously changing?
So I'm sorry, I didn't get the last part.
Yeah, so once you have optimized the system, how do you measure energy savings if the duty is continuously changing, or the circumstances is continuously changing, I guess?
Yeah, so once the system is optimized, and it's important to note for which conditions the system is optimized. Now, if we're talking about the supermarket air-cooled condenser, we may do the optimization during winter, but we also might see some issues during the summer. So it's important to take into consideration the conditions that we might have for this particular system. And once we do those optimizations, it's important to set alerts. So once we have the alert, if anything is deviating from our optimization, we can directly get an email or SMS telling that something there's an issue with this particular component of the system, and we need to take a look at it. Of course, in this case, we come back to the what Niklas was saying about having a responsible of this system. So it's not enough to put the predictive maintenance there. It's part of the steps is to have a responsible for this maintenance that takes the alerts and then decides to contact the contractor to make the changes.
Yes, and this also one thing that is important with predictive maintenance. We usually don't go into predictive maintenance project that is shorter. If it's just 1 year, it's because you need to see so many different operation conditions. I mean, in Sweden, you probably need 6 months to have a good view of the operation. So this is, even if we can find some problems are obvious directly, but optimization is an ongoing project, and the energy signatures is a huge help in this to keep track of this. But system efficiency index take the performance of different conditions into account. So it keeps track of that. Yes, Lars.
Okay, thanks. Let's move on to the next question. We still have sort of 3 to 4 minutes to go. If we don't have time to answer all your questions, the system will save the questions so we can get back to the answers after the webinar. So please continue to send in your questions. We will definitely answer them after the webinar.
Yep.
But let's move on to this one. Most condensers are cleaned on a Saturday morning, ? We should be able to see improvements in SEI after cleaning. Perhaps ask for pictures from service company.
I mean, if there is an issue with the condenser and the issue was that it needed cleaning, and if it's clean, then yes, we will see a difference in the system efficiency index. We will see a difference in the condenser performance. Now, us are not on the field doing this cleaning or doing these changes. So it's not often that we get pictures. Most of the time we get pictures of very dirty condensers because it's funny, but we don't get the pictures after it's cleaned or when it was cleaned. So these details, we don't always have it, but it's of course possible to see it on the graphs.
So it actually happened, which is very good to know. All right, so let's move on to the next one. We will be able to cover some more questions here. So how to use SEI in comparison with COP, which most suppliers use?
The main difference here is that the COP is dependent on the ambient conditions. Now you have a very good optimized system, and if I ask you what should the COP be, I don't really have an answer to that. Should it be 3, 4, 5? It really depends on the system. It really depends on the operating conditions. COP 3 in the winter may be really good, but in the summer, not so good. So it really, if we change the conditions by 1 degree, we're changing the COP few percent. So the SEI will take care of that because the SEI compares to a system without any losses in the same conditions. So if we have a winter in our system, our compared system, which has no losses, is also in the winter. So we can compare what our COP is to the ideal COP. So it doesn't matter if my COP is 8. It might still be not optimized. It can be 9, 10. So having a COP number is not always a good check to see if we can further optimize the system.
Okay, thanks for that. It's now almost 5 o'clock Central European time, and it's time for us to wrap up this webinar. So the thing that will happen is that tomorrow you will receive an email. In this email, you can find a link to the recorded version. You can find a link to the checklist that Niklas showed you, so you can do that analysis yourself, and also, of course, get in contact with ClimaCheck to discuss how to improve your situation. And you will also get a link to the presentation in PDF format and of course the contact details. With that, I would like to say thanks for everyone that took your valuable time and joined us for this webinar today. And maybe some final words from the speakers before we close down the webinar for today.
Yeah, thank you very much for being here. I'm looking forward to get in contact with you after this. Like Lars said, I think we will try to put the questions together with the webinar, so when you go into the landing page, we will have the questions there if it's possible. So thank you very much for today, and I'm looking forward to, I guess, save energy together in the future.
Thank you.
Yeah. So thank you, everyone. Take care out there, and continue to work with your sustainability strategies and improve your sustainability. So thank you, and bye-bye. And we will now close down the webinar.
Thank you very much.
Thank you.
See you.